So, good evening, all. So, welcome to the week one live interaction session, our very first live interaction session. So, let's just wait for a few minutes as I see some of them are joining still. After few minutes, let us start our session. And I hope I am audible. Can anyone please confirm? Yes, Tirumurti Kannan, you have raised your hand. Okay, let me. Okay. So, since it's our first live interaction session, so let us begin with something before. Let us begin with the introducing ourselves. So I would like to, you know, any one of you to start introducing yourself so that others can follow you. Just introduce yourself, your name, and then what you are doing, and why are you interested in this particular course. So I think we can start our session for today. So yeah, we have a good strength. Okay, so let me just share my screen. I hope my presentation is visible and I'm audible.
Yes, sir.
Okay, okay, yeah. Thank you for confirming. So let's start our session. So, good evening, everyone. I welcome you all to the week 1 live interaction session for the course Technologies for Clean and Renewable Energy Production. This course is offered by Professor Prasenjit Mondal sir from the Department of Chemical Engineering, IIT Roorkee, under the NPTEL SWAYAM program. So myself Pratyumnan, a PhD research scholar from the Department of Chemical Engineering, IIT Guwahati. So I conduct live interaction session for this particular course in this semester, July to November 2026. So in this course, as you see, the title itself, it speaks for itself. The title itself speaks for itself. Technologies for clean and renewable energy production. So we will be focusing on more on the aspects of how to produce energy which is clean and renewable. The major reason why we are focusing on clean and renewable energy production is basically because of the sustainability issues that comes up with the normal fossil fuel. As you all are aware, the fossil fuel that we use are are in constant depletion. The major reason being is that the population is increasing. So as the population is increasing day by day, the amount of energy demand is also increasing. So with the increase in the demand for the energy, the use of this fossil fuel is becoming or is increasing day by day. So since these fossil fuels are non-renewable in nature and they cannot be replenished back, so they are depleting, and this has basically led to the search of humans for some other kind of sources of energy which is renewable in nature. That is, it can be reused again and again, or it does not gets, or its energy reserve does not gets depleted. You have it always remains, so that humans can use that particular energy. It's not like fossil fuels where there is a depletion in the energy. So that is majorly the focus of this course. As I mean, that is basically the need of the hour for the entire world to basically look for energy resources which are renewable in nature, which are clean in nature. At the same time, that is also the focus of our course for this particular semester's technology for clean and renewable energy production. So the word clean is basically because the when you use fossil fuel for the energy production, it actually produces toxic gases, or it basically leads to gas emissions like carbon dioxide, nitrous and sulfur oxides, which can cause harm to the environment. So we basically need to also, along with the renewable, we also need to think about the sustainable aspect of the energy resource that we are looking for, so that it needs to be clean. So we will be discussing about more on this renewable energy production as we keep going towards the course. Since it's our very first live interaction session, in this particular live interaction session, we will understand how energy is important, or how energy is basically a currency, or is an indicator for the prosperity of the nation, and how coal is basically used as an energy resource. We will talk about the properties of the coal, its characteristics, and after that we will basically discuss how to produce energy from the coal. So basically when we talk about energy production, one of the major things that we need to see is about one of the major things that we discuss about is the GDP, gross domestic product, because the major reason is because the current energy technologies relies on fossil fuels, and so if more energy production is focused, it will lead to, so because of that particular reason we focus more on the GDP. So anyone who knows what is the just a second. Extremely sorry, there was a net. Extremely sorry, there was a network issue. I don't know where I left actually. So, okay, let us just a second. So, let us just start. So, as I was, I was just telling why we are basically um, going for clean and renewable energy production. So, the major reason is because the fossil fuels that we have are, I mean, the energy demand is increasing day by day as the human population is also increasing. So, because of that increased energy demands, we basically look for using this fossil fuels. However, the fossil fuels are non-renewable in nature. They cannot be replenished back once it is used. So, due to that, what happens is there is a continuous depletion of the fossil fuel. So, this has led to the human beings to search for various other sources of energy which are renewable in nature, which can be replenished back. And another aspect of fossil fuel is its sustainability issues. I hope all of you can understand. In case of the sustainability issues, what happens is these fossil fuels, when they are basically used as an energy resource or when they are burnt, it basically generates uh, it basically leads to gas emissions like carbon dioxide, nitrogen oxides, and sulfur oxides. So these can actually cause harm to our environment. So that is basically becoming a additional aspect to look at, that whatever energy that we are basically looking for, the renewable energy, they should not just produce energy for us or basically provide us with the energy, but also it should be clean and safe for the environment, from the environment perspective. So in this course, so that is basically the need of the hour, and that is why we are also typically interested in this course on understanding, or basically interested in this course on technologies for clean and renewable energy production. So the thing is, in case of energy production, as we say, we need to basically see how to improve the efficiency of the energy production, and um, how to produce more energy, and how to improve the efficiency of the energy production. So in so relating to these two, so when we talk about, when we think about this energy production and energy efficiency, the very first thing we basically come towards discussion is something so called as GDP. I hope, since all of you actually went through the course, can anyone let me know what is GDP? Yes, anyone? GDP. Oh. GDP. Anyone who knows what is the full form of GDP?
Gross domestic product.
Gross domestic product. Yes, exactly. And how do we define this gross domestic product?
Like calculating the consumer spending, government spending, business spending, and net exports.
So first is basically the consumer spending, then you have the government spending, then you have the business spending, and then you have the net exports. So C is the nothing but, just let me write it quickly. Consumer spending, your G is government spending, Your I is your business spendings, and your NX is nothing but the net exports. Apart from that, you have another one parameter that basically, just in case if anyone's mic is on, you can mute, because I think that is creating some disturbances. So apart from this GDP, there is another one thing that is called as energy intensity, which is nothing but energy consumed per dollar of GDP produced. So my question is, what does these two terms actually convey to us? What does this GDP and then this energy intensity? What is the physical? I mean, what is the significance of these two quantities, GDP and energy intensity? Anyone? What are the why we discuss about the concept of energy intensity and GDP, or how they are related to?
Like it could be helped in understanding if like your GDP is increasing, the per capita or like per energy is also increasing in per country, like such.
Hmm. So it basically gives us an idea of how much amount of energy is actually getting produced, and then how much we are basically using that. So it basically provides us a kind of an estimate on the how on the efficiency with which the energy is being produced and used up within a country. So for understanding that, we basically rely on these two variables, that is the GDP, gross domestic product, and another one is energy intensity. So as I just talked about the fossil fuel, in India, 17.5 percentage, that is the figure that is quoted in the lecture as well. Just a second. In case if anyone's mic is on, kindly mute it. I think okay, now it is fine. Because it was clashing. So 17.5 percentage of the, so 17.5 percentage of the energy that is basically being produced within the country or within India is basically comes from the renewable energy resources. The rest 59 percentage of it goes to goes to coal. So coal is basically used for the energy production. So if you can remember, there is a pie chart within the uh, class lecture. So over there, if you see, you can actually see the exact figures on how much amount of the energy that is actually produced from the renewable energy resource, and how much is actually produced from coal, and then how much is basically going towards the petroleum. So if you see, for any country, their major source of energy, or yeah, the major raw material that they use for energy production is nothing but petroleum and liquids. Then it comes to natural gases, then it comes to coal, and then it comes to renewable. And since I talked about this pollution aspect and sustainability aspect and the depletion of these, the use of renewable energy resources is increasing as years pass by. So the percentage of how much the energy contribution comes from this renewable energy resource has been increasing ever since the last decade. So just so in that way, if you see, in India, 59 percentage of the energy production still happens or still uses coal as its raw material. However, 17.5 percentage actually comes from renewable energy resources. So when I say renewable energy resources, I mean solar energy, hydrothermal energy, geothermal energy, wind, and then tidal energy. However, tidal energy in India is not basically very developed, but yes, that they do provide a very small contribution to the energy production that happens through these renewable resources. So, majorly the fossil fuels that we were discussing, one of the reason is basically the pollution aspect, right? So energy production is happening and it's basically being an effective source for energy production. However, the major problem is basically the pollution. Now, what can be done in this context so that we can try to, I mean, since renewable energy is still in its infancy stage, or it is basically in its developing stage, what can we do in this? Just a second. Just a minute. I mean, somebody's new mic is on. Mr. Shushil, can you please turn off your mic? Yeah. So I think now the audio will be clear. So yeah, that fossil fuels that we yeah. So the fossil fuels that we were talking about. So in case of coal, if you see, yeah. So the fossil fuels still they contribute to a major source of energy in India. However, we basically now since renewable energy is still in its developing stage, we basically need to start focusing on strategies on making this fossil fuel itself as a cleaner resources of energy. Like what can be done so that we can make fossil fuel as a cleaner route for the energy production. So any ideas on that? Any ideas on that? Just a second. So we have we have coal, the fossil fuel. Now we basically need to make this fossil fuel, since majority of the energy production happens from the fossil fuel, what strategies can we implement so that we can reduce the pollution that or reduce the gas emissions that happens because of these fossil fuels? Any kind of strategies? Yes. Any kind of strategies that we can implement? Anyone in with any idea on what to do? So basically, we can either go for some sort of a modification to the current technologies that we have, or we can actually go for a complete new technologies that can use this fossil fuel to basically produce energy. So when we go for this modification with the current technologies that we have, let me just type this. So the modifications, one thing that the major reason why your feedstocks will basically release harmful or toxic gases like nitrogen oxides and sulfur oxides is basically because of the impurities that are present in the feedstock. So one thing is doing feedstock cleaning. So wherein you basically remove sulfur and ash content in them. Then you can do some sort of design modifications. The next one will be introducing new technologies. Introducing newer techniques. So the first one is modification. Either you do some kind of design modification to the system so that you can basically produce a less gas emissions and then make the process more, so that you can extract more energy but at the same time lower the pollution rate. Or you can do feedstock cleaning, that is remove the sulfur content and ash content in the feedstock. So by doing that, you basically reduce the harmful gases that gets emitted as a process of burning this fossil fuel to get energy. Or other than this is nothing but the next route is introducing newer technologies. For example, gasification. So majorly in case of this coal or the fossil fuel that you basically do combustion. So what you do is you basically supply excess of oxygen and then burn the material so that it basically gets converted to volatile gases and then that energy can be used. Whereas in case of gasification, what you do is you basically provide a controlled supply of oxygen. You reduce the oxygen content. You don't supply excess of excess of air, that is which is greater than its stoichiometric quantity. You provide oxygen in a controlled manner so that the amount of carbon dioxide that gets emitted from the processes also will be in a controlled manner, so that you can easily capture this carbon dioxide. So it's some sort of a carbon capture that you can do through gasification process, which may not be possible in case of the combustion one because of the excess of air that is basically used for burning this fossil fuels to get energy. So one is gasification and another one is oxy fuel combustion. Third one is chemical looping. Fourth one is direct liquefaction. Again, the list is quite exhaustive in nature. I'm just giving few examples of the newer technologies that can be introduced, because in all these technologies the major goal is basically to make sure that the harmful gases or the gas emission that takes place or the flue gas whatever gets emitted is emitted at a very controlled rate, so that you can actually capture them for further processing, so that the pollution or whatever this flue gas that gets emitted to the atmosphere, that particular quantity is decreased, so that the process is more sustainable in nature. So this is about the fuels as such, talking about why energy is basically important, or how we can use this GDP and energy intensity as a parameter to basically know about the per capita consumption and the production of the energy and the energy efficiency analysis. Then we basically deal with the why there is a need for this clean and renewable energy production, and what are the drawbacks that we are facing now, and if we are using fossil fuels, then how to basically produce more energy but do that process at a much cleaner rate, sorry, at a much sustainable way, in a much sustainable way. So after this, yes, yes, anyone? Uh, yes, I think somebody has a doubt. This says Manas had a doubt. Is there anyone? Somebody has any doubt here? Okay. Anyway, even I was also about to ask any doubts, or can we progress how coal is basically used as an energy resource? Yes, anyone? Okay. So moving on, we have a topic where we now here we have discussed about fossil fuels. Next, we move on towards how coal is used as a source of energy. Oh, sorry. Coal. So, anyone who knows what is coal, like the exact definition or how it is described in the course content? Coal, or how coal is formed. This, I think, probably many of you will be aware of this because this is something that we are learning since our elementary grades. I mean, school level. So, how coal is formed?
by the process of qualification.
Okay, what is that qualification process? I mean, okay,
Uh,
qualification is a process. Yeah, go ahead.
like it is formed from the plant materials and it will decay for a long time from which the coal is formed.
So basically, what is the thing is the plant and animals. So when they die, their residues or their remnants, whatever that remnants that gets that is present in the environment, when they basically get accumulated for millions of years and undergo some sort of a geochemical action, or when they are subjected to high temperature and pressure. Yes. So, as I was saying, when these plants and animals decay for a millions of years under high temperature and pressure, the coal is actually formed. So, the exact definition how the course content reads is partial decay of plant materials accumulated for millions of years and is altered by the action of heat and pressure. As somebody said, it's also the process of formation of the coal is also called as a coalification process. So, wherein this plant material forms undergoes this geochemical action, and then they form peat, then they form lignite, and then they form bituminous, and then they form
They
anthracite. So this process is called coalification process. And in case of this bituminous coal, if you see, there are sub varieties. So does anyone have any idea? In case of bituminous, there are totally three different varieties of bituminous coal. So one thing is called semi bituminous. Second one is bituminous, and third one is subbituminous. So this process is called qualification process, wherein this plant material is converted to, or it gets transformed into coal. So this happens as in the form of a stages where you form peat, lignite, bituminous and anthracites. So the percentage of carbon that is present in this coal basically influences the amount of energy that gets produced. So higher the carbon content, it basically gives more energy. So when the carbon content is going to be more, the amount of energy that is going to be generated in the process is going to be higher. Similarly, if your sample is going to have lot of volatile matters as well as the moisture that is going to be present, then those kind of coal will not basically give more amount of energy, or their efficiency with which the energy that gets produced is going to be low. I hope everybody is able to understand when I say why, when moisture is present, the energy or the coal is becoming undesirable. Can anyone explain? If a particular sample, coal sample that we have has high moisture content, then it is basically not desirable for energy production. Why?
because it lowers the heating point.
Basically, it lowers the heating value because you need to supply more amount of energy for the moisture to be evaporated, or the moisture to be, or moisture and the volatile matters to be removed. Then the carbon materials in the sample will basically produce energy. So you need to produce more amount of energy to extract, or the input is going to be more, but then the output is going to be the same. So the efficiency of the process is going to decrease. So that is the reason those kind of coal samples which have more volatile matters as well as this more moisture are kind of less desirable. So coal which is aged, just a second. Coal which is actually aged and have higher carbon content is going to be desirable. However, the coal which has more moisture and volatile matter is going to be less desirable. As somebody rightly said, why it is less desirable? Because more amount of energy is basically required to evaporate the moisture. The heating point value decreases. I kindly request people to mute the mic because it's interfering with the recording, because this video is getting recorded, so it will be uploaded, so then the voice will not be clear. So kindly mute your mic. So this is more desirable, and the next one is less desirable. Again, if you have any doubts, you are welcome to speak out. But in case if you do not have any doubts, then please mute your mic. So a more desirable coal will basically be a high ranking coal, whereas a less desirable coal will be a low rank one. High rank coal, whereas the less desirable one will be a low rank coal. Now, based on the origin of the coal, there are totally two theories that are proposed. One is the in situ theory, and another one is the drift theory. So now we basically know that coal, if it has more carbon content, it is basically a high rank coal and it is more desirable because it basically produces more energy. However, if a coal is basically has more moisture and volatile matters, then they are less desirable coal and are low rank coal, because the amount of energy that is going to produce from these kind of coals is going to be less. Now we basically talk about the origin of coal. So based on the origin of coal, there are totally two kind of theories that have been proposed. The first one is the in situ theory, and then the second one is the drift theory. So in case of in situ theory, what it states is the coal over in these cases are actually formed by the accumulation of the vegetable matter that are grown in swamps. Again, all these contents are covered in the weekly lectures. Here I am just kind of like brushing up as soon as possible, so that we can have a so that we can all recollect the memory of what we learned in the course over the week, and then we can move towards solving some of the problems for the today's session, so that we will start within the next 10 minutes or so. So accumulation of vegetable matter grown in the swamps. Whereas in case of the drift theory, here it is about the terrestrial plants, terrestrial plants that are growing in dry lands. Their debris are taken by water and are deposited underwater or underwater in the lakes. So these are the two theories that are associated with the origin of the coal. But coal as such, it basically has a certain drawback. One of the major drawback is that the mechanical strength of the coal is not very appreciable. So they tend to basically break into powders or some sort of the granules. So coal as such, when you basically want to use this for some application, especially when you want to do this furnace, the oven applications, the coal is not that very kind of like, what do you say, a suitable candidate, because its mechanical properties are very bad. So in order to basically improve upon the property, the coal is actually transformed into coke. The major reason why we do this is basically because the coke has the mechanical properties. So what we do here is we basically take the bituminous coal, and it basically undergoes destructive distillation, and then once the destructive distillation happens, you basically get the solid carbon. Just a second, just a minute. Okay. Let me finish the session for today, then we will see. So, coke is nothing but it is basically the solid carbon that are formed by the destructive distillation bituminous coke. And any idea on why we typically use bituminous? I mean, as such, in a coal we saw many types of, right? Peat, anthracite, bituminous. But in case of formation of coke, we basically use bituminous coal. Any reason?
Sir, it is a low moisture and low BM cooking coal, and it is a high strength
It
cooking coal.
basically the bituminous content that's exactly right. So the bituminous content that is basically present in the coal helps in binding the coke. So it basically provides the sufficient mechanical strength for the coke so that they can be used in variety of different applications. So there is another process which is called caking. Here what actually happens is the coal is basically treated, or the coal is heated in the absence of air, and then the coal swells with the coherent residue. This process is called caking, and then the coal that is produced through this process is called caking of coal. So this coal is actually used in the steam turbine. So we basically will deal, so once we start talking about the energy production, we basically deal with the two types of concept or variables, that is HV and LHV, that is higher heating value, and LHV is nothing but the lower heating value. So kindly look at the course content on the formulas for HV and LHV, because we will be solving problems based on that. Now, as such, when we talk about the properties of the coal, we basically have to talk about two different type of analysis. One is your proximate analysis and another one is the ultimate analysis. So in proximate analysis, we are particularly interested in knowing about the percentage of ash, percentage of moisture, the fixed carbon and the volatile carbon. Whereas in case of ultimate analysis, if you see, we are basically interested in knowing the chemical constituent that are present in the coal. That is percentage of carbon, percentage of oxygen, percentage of hydrogen, sulfur, nitrogen. So in order to do this ultimate analysis, we basically take the help of a CHNS analyzer. So CHNS analyzer is one wherein your wherein your sample is basically treated or is basically heated at a high degree, at a high temperature of 990 degrees Celsius in the presence of pure oxygen. So once this process happens, the carbon in the sample gets converted to carbon dioxide, sulfur gets converted to sulfur oxides, hydrogen gets converted to water, and nitrogen gets converted to N2 or N2 oxides. After this, it is basically sent through the silica tube, which is basically loaded with the copper granules for the reduction of this nitrates and nitrous oxides. Once that is done, it is sent through a gas chromatographic equipment where the where you can actually determine what percentage of carbon is there, what percentage of hydrogen is there, what percentage of nitrogen is there in your sample. So whereas if you see in case of proximate analysis, it is basically dealing with the more often of simply heating the material at various different conditions to find out what would be the percentage of moisture, ash, fixed carbon and volatile carbon. You don't need to do any kind of special analysis, unlike how do you do in case of ultimate analysis, to understand the percentage constituent present in the sample. So next concept we will be talking about is the bomb calorimeter. So I hope everybody is aware about the concept of bomb calorimeter, and I think this is something that is is basically taught across different courses as well. So here also we basically use this bomb calorimeter to basically find out how much heat energy is released during the combustion. So coal or the waste material, basically speaking here, it is our coal that is basically is which is used for the combustion, is kept in the bomb. So this is the bomb that you see. It is kept in the bomb, and then excess of oxygen is basically pressurized within the system. Now this entire system is basically submerged within the bucket, the water bucket, which basically has a known volume of water. Once this is done, the bomb is ignited. So once the bomb is ignited, the combustion process happens, and then the heat is released. The heat generated, what happens is, once the heat is released, the water that is surrounding this bomb basically absorbs the heat or gains the heat, which basically results in an increase in the temperature. That temperature change, in order to detect the temperature change, you have a thermocouple. So that delta T is basically recorded by your thermocouple, and then with that particular increase in the temperature, we are able to find out how much heat energy is actually released during the combustion process. One of the main things that we need to note here is, or we need to understand here is, energy as such cannot be measured with any kind of equipment. So heat energy that gets released, you do not have an equipment to measure that heat. What we can do is, we can only measure the increase in the temperature, and based on that increase we can correlate how much energy has been actually produced. And so kindly remember this, because this is something very fundamental. We cannot measure heat, we can only measure heat in terms of temperature. The delta T that increases, or the delta T that changes, the value that changes, basically provides us information that heat is either released or added to the system. So based on that, if you see, that's how the working principle also goes. The heat that gets released during combustion is nothing but the heat gained by the bomb and the water. So heat that is basically gained by the bomb as well as that of the water is basically the amount of energy that is released during the combustion. So if you write the equation, you get delta H as mb, that is mass of the bomb, cpb, that is the specific heat capacity of the bomb, plus mass of the water plus specific heat capacity of the water times delta t. So these two put together is written as delta H is equal to W times delta T, where W is the water equivalent. So this is the bomb calorimeter. It's very simple, and this is basically one of the techniques that are used even in the recent days to calculate the amount of energy that gets produced by the combustion of a material. So very simple. Take the material, place it in a bomb, pressurize the system with the excess of oxygen, and then submerge the bomb or the material filled bomb inside a water bucket with a known volume of water. Now ignite the bomb. So once the ignition process happens, combustion happens. As the combustion happens, heat energy is released. That heat energy that gets released is basically absorbed by the water, and this gaining of the energy that is gained by the water basically results in an increase in the temperature, and that actually is detected by a thermocouple. So once you can have that reading, that delta T, you can directly correlate how much amount of heat energy is released, and you know the mass of the bomb, and you know the mass of the water that you're taking, and you know the CPW and CPP. So once you know all these parameters, you can calculate how much amount of heat energy is released during the combustion process. So here we finish our discussion on the concept. Again, this is a very brief overview that I have given. It's not extensive or exhaustive by any chance, because there are so many other things that are discussed in the course as well. So please have a look at the course. Here, since our session is confined for only 2 hours, we may not be able to discuss more of the concepts. So, if you have any doubts, you please let me know now, or else we can go towards solving the problems. But again, I request all of you to please go through the course content so that you can get more in detail knowledge about the different concepts that are discussed there. So, in case if you have any doubts, you're welcome to raise your questions now. And for those who do not have any doubts, kindly have a look at the following questions. Is anyone with any doubts? No. Anyone, any doubts so far on what we have discussed? Bomb calorimeter, then proximate analysis, ultimate analysis. We will be solving questions also, so yeah, so no need to worry about that. And then the properties of the coal. Anyone, any doubts? Okay. So let's just take a short break. It's not going to be a big break because we just have completed this session on discussion of concepts. So very short break for 3 minutes. So we will resume our session by 6:10. So since it's a 2 hour long session, we know, I mean, going continuously for the entire 2 hours may not be a very good choice, as have seen throughout, I mean, for multiple other sessions as well. So let's just take a short break for 2-3 minutes, not more than that. Till that time, for those of you who would like to solve the questions, please have a look at the questions. For others, you can either ask your doubts or you can go for your break and then come back within within a short time. Anyone with any doubts? So are the answers ready? So what about question 1? Type of coals found in the Indian subcontinent. Yes,
Lignite and bituminous.
lignite and bituminous. Okay, any other answers? Anyone?
Sir D.
Peat and lignite.
Peat and lignite. Okay, anyone else with any other answers? So two answers are being said. One is peat and lignite, and another one is what do you say? Uh, I think lignite and bituminous. Somebody said, right? So which is correct?
No, sir, peat and lignite. Peat and lignite.
Peat and lignite. So the answer is lignite and bituminous. So these are the two types of coals that are found in the Indian subcontinent. So you can actually look at the course content. So over there, if you see, the only these two, lignite and bituminous, are the types of coals that are found in the Indian subcontinent. That is what is actually mentioned. So please have a look at it. So this lignite and bituminous, are they high rank coals or low rank coals?
Sir, bituminous is a high rank coal.
Hmm.
Lignite.
Yes, lignite.
Low rank coal.
Low rank coal. So if you see for peat, lignite, bituminous and anthracite is the highest rank coal and the peat is the lowest rank coal. And the major reason behind the ranking is basically the percentage of carbon in the sample. So anthracite has more percentage of carbon, whereas your peat has less percentage of carbon present in them. So I, I hope you remember, higher the rank of coal, higher the carbon content in the coal, higher the rank of coal, because more amount of energy can be produced and that is more desirable for our application or for our need. Whereas a lesser desirable, a low carbon content one is basically a less desirable one because you are not going to get that much amount of energy and hence it gets a lower rank. So what about question 2? Match the type of coal with their carbon percentage.
Lignite has 25 to 35 percentage. Subbituminous
Okay.
has 35 to 45 percentage. Bituminous has uh,
Bituminous has
45 to 86 percentage.
and last one anthracite.
86 to 98 percentage.
Yes. So the anthracite basically, as I said, it has high percentage of carbon. So that comes, so 86 to 98 percentage of carbon is basically present in anthracite. So as somebody rightly said, lignite has the lowest one among these. So among the four, lignite has the lowest one, which is P3. Then Q, sub bituminous basically has more, so that is 35 to 45. Then bituminous has even more carbon percentage, so R is 2. And anthracite is the one with the highest percentage of carbon, so 86 to 98 percentage. So P3QR, sorry, P3Q4R2 and S1. Any confusions here? Anyone?
No, sir.
No. Okay. So, shall we progress towards question 3? Then, net calorific value is the gross calorific value less than the dash heat of water in the product of combustion when cooled. So, is it sensible and latent, or none of this?
Latent.
Latent. Any other answers? So, what is the difference between sensible heat and latent heat? Before answering the question, what is the meaning of sensible heat and what is the meaning of latent heat?
Temperature like mostly changes without changes the state, and like latent is the state of the object, anything.
So, in case of latent, you say there is a change in state and there will not be any change in temperature, right?
Yes.
Okay, a change in phase, but without changing temperature. So something like hidden, that is what the word latent actually means. Then what is sensible heat? Have a look at it because this is fundamentals, right? So have a look at the internet on what is latent and sensible heat and what is the difference between both of them. But we will discuss this in the next session. I'll mark it now. I want people to go and have a look at it. Definition and difference. Mm. So, however, the answer to this question is latent heat. So, net calorific value is gross calorific value minus the latent heat of water in the product of combustion when cooled. Answer is right, but question is what is the difference between sensible heat and latent heat? Please have a look at it because this is fundamentals, because this we basically deal whenever we discuss stuffs related to the change in temperature and change in phase. We use these concepts far more frequently, specifically while dealing with the thermodynamic cycles. So please be careful in them and have a look at this, um, both the terms as well as their difference. Try to understand their difference. Next, moving on. Question number 4. In proximate analysis, moisture percentage is measured by drying the sample at dash for 24 hours. At what temperature do you dry the sample so that you can get the moisture percentage? Is it 90, 80, 105 or 120?
105.
105. So this is standard and we cannot change it. So this is how the guidelines has been defined, that if you dry a sample at 105 degrees Celsius for 24 hours, by taking the weight of the sample before drying and after drying, if you subtract the percentage of the moisture that remains within the or you can say, if you take the weight of the sample before drying and after drying, if you take the weight difference, that difference basically represents for the weight of the moisture in the sample. So that's how you find out the moisture percentage using proximate analysis. So similarly, just like how do you do for to calculate moisture percentage, like that you have also for volatile matter, calculating fixed carbon and calculating the ash percentage. Different guidelines are basically available on what kind of techniques or treatments that you need to do so that you can get there respective percentages. So kindly have a look at it. It is there in your course content. I will also put up a what do you say, along with this slide. I will also write it in a box and highlight it, but please go through the course as well. So moving to question 5. This is question 6. For a coal-fired utility boiler, temperature of the high-pressure steam is about 800 degrees Celsius. T cold, that is your cooling tower water temperature, is about 75. Calculate the Carnot efficiency of the power plant. How do you calculate?
One minus T cold upon T hot.
So that into 100. So what will be the value?
Is 67.5%.
Okay, so how do I write this? So Carnot efficiency is nothing but 1 minus T cold by T of the high pressure steam, right? So that will be, so you need to change it into Kelvin. 75, right? So 75 plus 273 by 800 plus 273. So what will be the value? I want the individual values. So 1 minus, how much is this? 358 if I'm not wrong, by 1073. So what is 358 by 1073? Just let me quickly calculate. Oh, there is 348 minus 0.324. So that is 0.676. Or you can, in terms of efficiency, if you write Carnot efficiency is equal to 67.6%. Oh, 67.56. So that is the answer. So 67.5%. Anyone has any doubts in this? No doubts, right? So shall we move towards the next one then? So next question is more simpler. Which of the following countries has the highest carbon emissions in the world? China, India, Russia, Brazil.
China.
China. So it is China and USA, but in the options we do not have United States, so it's China. So any doubts with the 6 questions that we discussed so far? Anyone? These are not that difficult, but again, if any of you have any doubts, then please let me know. Shall we progress towards next question then? Okay, let me just show the next question. Question number 7. You have two parts. So part 1 and let me just. Yes, yes.
भाई मोदी जी बड़े पैसे क्यों देंगे मेरे को
Hello. Okay. So in case if you have doubt, please let me know or progress towards solving these 2 questions. This is question 2. Assume it this way. Oh, am I audible?
Yes, sir.
Okay,
Yes,
okay.
sir.
So solve these 2 questions. So the first question is simple. Weight fraction of moisture content in a biomass sample. Consider the weight of biomass before the moisture removal has to be 9.23 and weight of biomass after moisture removal as 6.565. Basically, when I say before moisture removal, I mean the weight of the sample as received. What's the answer for the first one?
%28.9%.
28.9%. Okay, let's start solving. Since I received an answer, I'm going to start solving. So, percentage moisture is nothing but weight of the sample before minus after. So, just 9.23 minus 6.565. 28.87%. And so it's 28.9 percentage. So this will be the percentage of the moisture of the as received sample. But however, what happens if I ask calculate the weight fraction of the moisture content in the moisture free biomass sample? Then in that case, the weight of that the denominator will not be 9.23, it will be 6.565. So over there I'm going to calculate the moisture with respect to the bone dry sample. So basically if the question states that calculate the weight fraction of the moisture content in a bone dry biomass sample, then you need to basically divide that with the 6.565. Like if the it's all about what is the basis of calculation. So here the basis is as received sample, so that is the reason I'm going to put 9.23, right? So I hope all of you are able to understand. Any confusions here? So for this question, the answer is 28.9 percentage. Any queries or any questions? Anyone? No? Then shall we progress towards the part 2? Part 2 is consider a biomass sample of mass 6.24 mg. That biomass sample is being heated and to remove the moisture. 25% of its weight is basically lost as moisture upon drying the biomass sample. The bone dry sample is burnt at 1000 degrees Celsius to derive energy. The ash is recovered after burning and the weight was measured to be 2.53 grams. That is the residue whatever is left out. Calculate the percentage of ash based on the moisture free sample or a bone dry sample. It's very easy to be specific. You just need to calculate the moisture, the weight of the moisture free sample. Once that is done, you will be able to calculate the percentage of ash. Then what's the answer? Anyone answer? I'm audible, right? Hello.
%54.
64. Okay, let's start
54.
Okay, 54 percentage. Okay. Since I received an answer, I'm going to start calculating to check. So it's simple. So you just need to know what is the weight of moisture. That is nothing but 25 percentage of sample. So I'm going to write 0.25 times 6.24. 6.24. 1.56. So now you need to subtract this. So weight of bone dry sample is nothing but 6.24 minus 1.56. So how much is that? 4.68. Sorry, mg. Weight of ash recovered is nothing but 2.53 grams. So percentage of ash in moisture free sample is nothing but 2.53 by 4.68 times 100. 54.06 percentage. So somebody said 54%. So yeah, that's correct. So here the calculation is far more simpler because you just need to know what is the weight of the bone dry sample. Once you calculate the weight of bone dry sample, then you know the weight of ash that was actually recovered. So that by the weight of bone dry sample into 100 give the percentage of ash on the bone free moisture free sample, or you can also say bone dry sample. So both are equally acceptable synonyms. So any doubts in question 7? So if no doubts, then let us proceed to the next question. Yeah. Question 8. To determine the water equivalent of a bomb calorimeter, 1.51 gram benzoic acid with a high heating value of 8000 calorie per gram was used. The experiment produces a net corrected rise in the temperature of about 4 degrees Celsius. Acid titration required is 11.9 ml of standard alkali and 8 centimeter of par 45 C10 nickel chromium fused wire was consumed in the firing. Determine the water equivalent of the bomb calorimeter. How to solve this? Anyone? So then, with this question, we will end our session for today. So this is the last question. but I want answer, or at least how to go about the steps. Yes, Sunil, you have raised your hand. Do you have anything to say, or like,
So next class कब है?
yes?
When's our next class?
Next class is on next Sunday.
Okay, so we'll have every Sunday class, right?
Yeah, every Sunday.
And the exam paper would be in MCQ, na sir?
I don't have idea about that exam paper. So, if you want to know about the exam paper, then I think better you post this question in the Q&A section of the course.
Okay, okay. So are these question like important for exam point of
Yeah,
view?
that's the reason we are discussing, because these are the questions that you may get in your assignment also, and maybe might come in the final exam as well.
Also, how can we get this PPT?
That I will upload. So stay for another 10 minutes. So I will explain everything towards the end of the session.
Thank you, sir.
Okay. So we are asked to calculate the water equivalent. I think this is one of the solved problems in the tutorial. I mean, a similar problem has been solved. So delta H is equal to W times delta T, right? Now we are supposed to calculate the water equivalent, which is nothing but it's going to be WH by WT. Now delta H. How do you calculate delta H? It's nothing but mass of the sample times the HHV value plus E1 plus E2 plus E3. Now this E1, E2, E3 are basically, so when you do this process, some amount of the energy will be consumed. It's not that the entire 100% of the energy, whatever was combusted, is going to get transferred into water. Some of the energy may also be consumed for other purposes, like burning of this nickel chromium fuse wire. 8 centimeter has been burned. So over there also energy has been expensed. So we need to incorporate that as well while calculating the water equivalent of the bomb calorimeter. So how do you calculate E1, E2 and E3? M you know, HHV is given. How do you calculate E1, E2 and E3? So E1 is 11.9 ml times 1 calorie per ml. That is the specific heat of this standard alkali that we are going to keep. So that will be 11.9 calories. E2 will be 0 and E3 is going to be 2 point, is it 7 or is it 3? Just a second. It is 2.3 times 8 centimeters. So how much is that value? $18.4. So delta H is going to be, HHV is 8,000 calorie per gram times 1.51 plus 11.9 plus 18.4 divided by delta T, which is nothing but 4. So how much is this value? So 11.9, so wait. Let us first calculate that 1.51 times 8,000 plus 11.9 plus 18.4, the entire divided by 4. 3027.575 calorie per calorie per degree Celsius. I'm just going to copy paste. So is this the answer that you people are also getting? I mean, can you match your answers? Yes, did anyone calculate the, any doubts on how did we calculate E1, E2 and E3? This value 2.3 will basically vary depending upon the type of material of the wire that is used. Since it's here, it's a nickel chromium fused wire, I'm using the value 2.3. If it is going to be platinum, then it's okay. If it is going to be platinum fused wire, then it is going to be 0. So kindly keep your mic on unless or otherwise, unless or otherwise you have any doubts. Please mute yourself. So, any doubts with this question? So, we have two more questions, but these two questions we will take up in the next live interaction session, so that won't be any issue. So, if you have any doubts, you are welcome to let me know now, or otherwise, we can conclude the session for today.
No doubt, sir.
Okay. So, anything that you would like to discuss regarding the presentation, because we will be following this style. I mean, I'm planning to follow this style where we will dedicate some time to review whatever. I mean, not a very exhaustive review, but just a gist of what we did. So, what we did it in the course for first half an hour or so, or whatever time it takes, and then rest of the time focus on problems. So, in case if you have any feedback related to the way we are conducting the session, you are welcome to let me know. Or you can also type it in the chat box. So somebody asked related to this, yeah. So the presentation as well as the video recording will be available to you. So in the course page, if you go to this course page, technology for clean and renewable energy production, the 2026 semester, July November, you can actually see on the left hand side at the bottom problem solving sessions. So if you click on that link, you will be directed to an Excel sheet where you can find the YouTube recording of this video as well as the presentation file. So you can access both of them from there. And yes, we may have similar problems in the final exams, that I'm not sure how it is going to be conducted. But if you see in case of your assignments, you do have similar problems like this. So if you have nothing to share, then I think I can conclude the session
Sir,
for
could you
today.
please repeat?
Yes.
Sir, could you please repeat like where we can find this sessions link?
Yeah. So you have registered for this course, right? Technology for Clean and
Yeah,
Renewable Energy
yeah.
Production. So over there, if you go to that course, on the left hand side, you can see week 0, week 1, week 2, where you can access the course content. So at the bottom, if you see, there will be something called as problem solving session. If you click on that, you will be directed to a Excel spreadsheet, a Google Excel spreadsheet, where you can find the presentation file, this PPT file for this particular for today's session, as well as the video recording. So this recording will be uploaded to the YouTube and then the link will be available to you. So you can access both the video as well as the presentation file from there. So it will be uploaded within few days, like probably tomorrow or by day after tomorrow it will be uploaded. So you can have a look at it, and in case if you have any doubts, my email ID also will be available along with the presentation. So you are welcome to email me, or in case if you have any other doubts, as I said, you can also drop it in the Q&A section of this course. So there some, either me or some other TA uh, who who is the TA for this course will answer to that question as soon as possible or as soon as they can. So let's conclude the session for
Okay, sir.
today. I
Thank you.
think, okay, yeah, thank you. So yeah, thank you all for joining today's live session. So our next live interaction session will be on 2nd of August from 5 p.m. to 7 p.m. So I hope to meet you all there. So I also take this as an opportunity to thank Professor Prasenjit Mondal sir as well as the NPTEL team for providing me this opportunity to interact with you all in this Sunday afternoon. So thank you for joining today's session, and yeah, have a great week ahead and keep working on the course as well as try to solve the assignment problems. And thank you so much. Thank you. Bye.
Bye.
Thank you, sir.